So, binomial expansion. Do you know what I mean by expansion? Where have you seen that before?
Brackets.
Brackets, yeah, fine. Straight. So we're looking at expanding brackets. Do you know what binomial means? You know what bi means? Two. Yeah. So what we're looking at is being able to expand something along the lines of this. What should I say? Let's say n. Right. We're looking at expanding where we've got something plus something to the power of something. Right. So obviously you know what a to the power of something is on its own, don't you? You know what it means?
Yes.
What does it mean?
A times A
Times A.
Yeah. Repeated multiplication. A times A times A times A, and so on. Right. So if I said to you, all right, let's take first one really. Let's see whether anyone makes the massive error that they really shouldn't make. And we're dealing with quadratics. You've seen this before. Okay. Someone will make this mistake. I was just talking about it in my year 13s, I think. They all gave me permission to stand in front of them and laugh in the exam if they made this mistake. So I'm not going to do that with you because you're still learning. But if I asked you to expand that for me, what's the answer? Well, you're all scared now because you don't want to make a stupid mistake.
A squared plus B squared plus 2AB.
Okay, I thought you'd gone wrong. Who wanted to say A squared plus B squared? Who didn't have a clue either way? Okay, good. So the answer to this, what is A plus B squared? How would you rewrite
We've
it?
got two brackets.
There's two brackets. So we've got A plus B times A plus B. So you've seen that before in quadratics. X plus 2, X plus 1. Alright? But we're dealing with it in any situation now. So general form, something plus something times the same bracket. Okay? So we've got that squared. So when we multiply this out, however you want to do it, smiley face and eyebrows and blah, 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 we end up with A squared plus 2AB plus B squared. Right? Happy with that? What about A plus B cubed? Can you work that out for me? How would you do it? How would you go about it? Just to check so no one sits there and waits for everyone else to do it for them.
A plus B times A plus B times A plus B.
Okay, yeah, it is A plus B times A plus B times A plus B. But do you have anything already there to help you?
Yeah.
Okay, so I could just do A plus B times A squared plus 2AB plus B squared. So have a go at that and tell me what you think the answer is. Okay, let's have a look then, guys. So how have you done this? So first of all, the best way to do it is A times them all. So you end up with A cubed plus 2A squared B plus AB squared. Alright, so I've done A times all of those three. But then I've got to do B times all of those three. So it's plus A squared B. Alright, A squared times B. 2AB times B is 2AB squared. B times B is B cubed. Okay with that? Then simplify. So we've got A cubed. We've got 2A squared B. We've got another A squared B. So it's actually 3A squared B. And then we've also got a plus 3AB squared. And then we've got plus B cubed. Now I've written it in that specific way for a reason. Okay? That's what we need to get used to seeing. Right? Happy with how to do that multiplication? Right. I'm going to get all of you then to do, just as a practice, A plus B to the power of 4. So make sure you write out everything and then simplify. Do it in a nice, structured, orderly fashion. Don't guess. Don't try and do shortcuts. Right, so same thing. Take what we just did, multiply it by a plus b. Okay, guys. So generally you're there, aren't you? So we've got, before I tell you the answer, what we're going to have to look at is there a quick way? Is there something we can notice? Is there a pattern? It's that whole investigational approach that we need to consider and start developing rather than just do it. Because for instance, if I now said to you, I want to know what a plus b to the power of 18 is, okay, you would have to do in this method, it's power 4, work it out, it's power 5, work it out, it's power 6, and so on. We don't want to have to do that. Okay, so what we're looking for is a pattern. This is what binomial expansion is. It's about a quick way of getting straight to the answer without actually having to do smiley face and eyebrows. Right? So, the answer to this one, okay, hopefully you've got a to the power of 4, okay, plus 4, then this is where the pattern starts coming. A to the power of 3b plus 6, a to the power of 2, b to the power of 2, plus 4, a to the power of 1, b to the power of 3, plus b to the power of 4. That's the correct answer. Now what I want you to do, right, I want you to write all of them that we've done so far, one under the other. And what we're going to do is like this. So we've got a plus b was the start, to the power of 1, isn't it? Now, a plus b to the power of 2 was a squared plus 2ab plus b squared. So I'm kind of writing it in a triangle. A plus b to the power of 3 was a cubed plus 3a squared b plus 3ab squared plus b cubed. And then the next one, to the power of 4, was a to the power of 4 plus 4a cubed b plus 6a squared b squared, 4ab cubed plus b to the power of 4. Okay, so we've got a plus b to the power of 1, to the power of 2, to the power of 3, to the power of 4. Okay. Right. There's two parts to this that we can separate to help us work out another one. So, for instance, if I wanted to go to the next one, let's do a plus b to the power of 5, but without having to do the expansion, without having to draw the brackets, multiply out, collect the like terms. I want to go straight there. Now, take a minute, look at what you've written and see whether there's any part of it that you can use and go, ah, I know that's what's going to happen. Alright, have a look. If anything that jumps out at you that makes it really easy. There will be. Okay, let's have a look then. So, what I expected you to notice was something to do with, let's say, this power, and then the powers here. So it's a bit hard to spot on that one. Gets a bit easier, so 3. We've obviously got a 3 and a 3 there, yeah? That's easy to spot. So we've got a 4, and we've got a to the power of 4 at the beginning, b to the power of 4 at the end. Obvious. So A plus b to the power of 5. What's it going to start with?
A to the power of 5.
A to the power of 5. End with b to the power of 5. Now the question is, what about the rest of them? So that's 3. This is a to the power of 2, b to the power of 1. This is a to the power of 1, b to the power of 2. Which link to make? 3. 3 to the power of a to the power of 3, b to the power of 1, a to the power of 2, b to the power of 2, 1 and 3. Does the same thing work? Does it make 4? Okay. So, potentially then, if we were to have an educated guess at this one, we would say that it's going to start with a to the power of 5. What do you think the next one's going to be? Just the letters. Okay?
A to the power of 4 and
With a b.
yeah.
Because 4 and 1 make 5. What about the next one? A to the power of
2.
what? A to the power of 3. Why 3? Because it goes 5, 4, 4, 3, 2, 1. Okay? 3, 2, 1. This one will go a to the power of 3, b to the power of 2, because they've got right up to 5. The next one, a to the power of 2, b to the power of 3, plus, Antoine, next one?
5 to the power. Oh, sorry. Without the.
A to the power of
A to the power. No, not 1.
1, b to the power of 4, and then finally, b to the power of 5. Okay? What is that, by the way? B to the power of 5, a is to the power of what? So 0. And what's a to the power of 0? 1. That's why it works. The a goes 5, 4, 3, 2, 1, 0. And what does the b do? 0, 1, 2, 3, 4, 5. Okay. Make sense? So if I asked you now, if I said to you a plus b to the power of 8, do it with me. What do we start with? A to the power of 8 plus
A to the power of 7 plus b.
times b, yeah, plus
A to the power of 6, b to the power of 2.
plus
A to the power of 5, b to the power of 3.
all the way to a to the power of 2, b to the power of 6, plus a, b to the power of 7, plus
B to the power of 8.
b to the power of 8. Okay? Make sense? So that's the algebra bit. What's missing? The big numbers. Okay, so let's have a quick look at that. Let's highlight those. So we've got a 2, then we've got a 3 and a 3, then we've got a 4, a 6 and a 4. Is there any that you would like to have a guess at in here?
That's going to be 5.
So this one will be a
5.
5, okay?
And then 5, 8.
So 5a, b to the power of 4, yeah? Yeah, you think so? What about this one then? If that fits, this would be what?
9.
8, no? Why? 2, 2, 3, 3,
Oh, I thought you were
4,
in the middle one.
4, 5, 5. I'm going to go 8 there, yeah? I want to know this one. Okay, not these two, yeah? This one. And this end will be our 8 also, we think. Now obviously that's nice, but we've got to be able to do the middle ones. Any idea what you think these two middle ones could be? You think 8 as well? You think they're all going to be 8?
Well, I know it's the Pascal triangle thing. I forgot my words.
Okay.
So it's something to do with the 2 4s. No, 6. I think it's 8.
8. You're very close, but it's not 8. Because that would make 8. It's 10. It's 10. Right. He's right in that it's Pascal's triangle gives you these numbers. Okay? So that's what we've got to work out. We've got to work out what Pascal's triangle is. So I'm just going to write that down. So another bit of vocab then. To find the coefficient. So the coefficient is the number on its own. So not the algebraic stuff, it's the number that goes before the term. Right? So up here, this is a term. Okay? So that's a term in the expansion. Right? One term. How many terms in this expansion? For that one, 6. 6 terms. If that's a term here, that's a term. That is currently the coefficient because it's a number. Okay? These are variables. The number on its own is the coefficient. So what we want to be able to do is find the coefficient. And we are going to use Pascal's triangle. Okay? Does anyone already know Pascal's triangle? What is it then? So we have 1, 1, 1,
2,
1, 2, 1,
3,
1, 3, 3, 1. Now just point something out. 2, 3, 3. Got that bit. What's the next line? 1, 4, 6, 4, 1. Next line. 1, 5, 10, 10, 5, 1. Spot how it's done yet? Next line. 1, 6, 15, 20, 15. What? 6. Has everyone spotted it?
When you spot, I didn't spot the...
You haven't spotted it. That's fine, no, everyone. Go on, I'm trying to explain it. 1 and 1 make 2. 1 and 2 make. So you go like this and you add. 1 add 3 makes 4. 3 add 3 makes 6. 4 add 6 makes 10. 10 add 10 makes 20. Okay?
Yes.
So, what that means is, this 1 on its own is when you have an a plus b to the power of 0. Because anything to the power of 0 is just 1. When we have a plus b to the power of 1, it is just a plus b. 1a, 1b. But when we have a plus b to the power of 2, we have 3 terms, a coefficient 1, then 2, then 1, and so on. So this line down here are all the coefficients for a plus b to the power of? Shouldn't need to count if you've spotted it. 6. Because of this number here. This is 5, 4, 3, 2, and you've got the line 1. Okay. There's always a 1 at the end. Okay, so we should know then, to the power of 8, what do we need to do to find the coefficients? So it's got to be 1, 7, what is it? 21, 35, 35, 21, 7, 1, and 1, 8. We got that right. We've got the 1 in front, but we don't write it. What's the next one? 28. So this will be a 28. 21 is 56. 56 here. So what goes in front of this one? So obviously that's 8. This will be 28. Okay. And before the B is still the 1. Okay, so we found them. Make sense? Yeah? So, because you're all expansive thinkers and you're thinking, oh brilliant, yeah, I've solved that. That's a really good way of being able to do my expansion now. Because could I give you one and you could expand it now completely and not need to do all the bracket and thing, yeah? Pardon?
I'm not going to draw it the whole thing.
So what's the problem with this, sorry?
You need to start from 1 at a time.
Well, I've got up to 7 or yeah, I've got up to 8 now. But what is the issue?
Writing it all out.
Well, I'm going to have to do it anyway. I'm going to have to write it all out. If I want an expansion, right? If I said to you, remember I go back to here, I wanted to know a plus b to the power of 18, you'd have to write out anyway. How many terms are there in a plus b to the power of 18? 19 terms, good. Because it's a to the power of 5, you've always got a 1 without an a in it. So that leaves, so that's an important thing for you to remember. You will be asked that. This has 19 terms. Okay? You need to remember that. Be part of a question. How many terms in the expansion of? It's always one more than the power. Maybe that is an important note. Maybe put a little star, that's important. Okay? So if you have a plus b to the power of n, how many terms are there? N plus 1 terms. Okay, so that's an important note for you to remember. Alright? Now, if I asked you, and I never would, and neither would an examiner, ask you to write out all 19 terms of that expansion, you would be able to do it. That's not the problem. Because what's the first term? A to the power of 18. What's the second term? A to the power of 17 times b. That's not hard. What goes before the a to the power of 17 times b? What number? And what is that coefficient? The first one's easy. 18. It'd be 18 a to the power of 17b. What's the problem? The next one. Alright, what are all the other coefficients? So what happens in an exam is you will not be asked to write out all 19 terms. You will be asked to write one particular term out of the whole expansion. So I would say to you, for instance, just make a space here. So we've got this expansion, a plus b to the power of 18, and I want you to tell me the term in a to the power of 11. Okay, I want you to tell me that term. So you would start it by writing, well, it's a to the power of 11 times what? B to the power of 7. Okay? Make sense? Alright? Alright with that? What's the problem though? The coefficient. Now that is the question. What is the coefficient? So where's the problem with the method we currently have?
We don't know the top number. We have to go through.
You'd have to go through the whole of Pascal's triangle to get there. There is no way. We're going to do it this way. There's no other way. Okay, so obviously there is another way, right? There must be another way. Because if I'm going to ask you to do that, you must have a way of doing it. And this is what we need to move on to. It's the whole thing. How do I find the coefficients? First of all, I have to tell you notation. So what we write is this. It's actually, the coefficient has notation like this. NR. Okay? Also, on your calculator, NCR. Right? So, what we have, we've got to know what N and R are. So, N will be, well, actually, I'll tell you what, I'm not going to tell you what N and R are. I'm going to write it down. So here, let me get rid of the box. I'm going to write this and see whether you can figure out what I've written. It is and I'll tell you something else. 11, 7. No, sorry, I'm wrong. No, I'm lying to you. I'm not concentrating. Not 11, 7. This will make it clear to you now. Almost like I did that on purpose. 18, 7. That is the same as not. So I would say 18, 7 is the same thing as 18, 11. Same value. It's just a number, it's the coefficient. This is just notation. Can I ask you, first of all, where do you think the 18 and the 7 or the 18 and the 11 come from? Not the term, no. The power. Right, N, okay, is the power of the expansion. Okay, so there. So that's the N. Okay. What's R?
Power in a specific term?
Yeah. Now, what you will notice is it's 18.7 or 18.11 is the same number. Why is that?
Because it's either 8 to the power 11 plus 7 plus b power 11. 8 to the power.
Exactly. Remember, the coefficient, it's all symmetrical, isn't it? So 8 to the power of 11, b to the power of 7 has the same coefficient as 8 to the power of 7, b to the power of 11. It's the same coefficient, right? So we have the same value. So you can work out one or the other. And in an exam, when they say write down what the coefficient is, you can write either. But basically what they're expecting is it goes like this. So Pascal's triangle, right? The coefficients would be like this. So here, this first line would be, well, what expansion line is this? What's on the top? This line? 8, yeah? So it's 8, and then it's 0. So I know 8, 0 is 1. The reason is, the 0 is because it's b to the power of 0. And then we do 8, what do you think? 8, 1 is 8. 8, 2 is 28. 8, 3 is 56. The next one is 8, 4, which is what? What is 8, 4? 70. Work it out. Then 8, 5 is 56. So you can see that one and that one are equal. 8, 6. 28.
Can we stop this for a second?
8, 7. Sorry. Is 8, and then the 1 is 8, 8.
How did we get to the 7 point? No, like,
Because remember, I said this notation is for what the coefficient is. Okay?
coefficient.
So the coefficient will be 18.7. But that will give you a number, and we need to go from notation to number. Alright?
And
So,
how do you go?
well, it's Pascal's triangle. So I'm in row 8. Okay? That's the top number. The 8th power. So this was a plus b to the power of 8. Yeah, these are all the coefficients. Yeah? So it's 8, row 8 of Pascal's triangle. And then the bottom number is what b is to the power of. So b to the power of 0. So that's will be a to the power of 8, b to the power of 0. So we don't ever write that, do we? Okay? It will be 8, a to the power of 7, b to the power of 1. It will be 28, a to the power of 6, b to the power of 2.
So it's top number minus bottom number. 8 minus 2. 8 minus 4.
What do you mean by minus?
8 minus 4.
So for this one, 70, I know is it's 70. The 4 goes with the b, so then a is also 4 because it's got to add up to 8.
Wait, no, I got it. I thought you were working from 8 and 4, and that's how you got 70, and I'm like...
No. You can't use 8 and 4 to get to 70
Yeah, I know, that's
directly.
why I
No,
was
it's just notation. It's just notation. Anyone else got issues like that? It's just notation. So if I work out 8, 4, using a method I have, and I'm going to give it to you, right, you would get the answer 70. 8 over 4 is just notation. Okay? Make sense?
So without doing anything to 8 and 4, you cannot get to 7.
Well, we've got a formula that uses 8 and 4, but in a well, it's not complicated, but it'd be different for you. Right, but does everyone understand that the 8th 4 in this case is just notation for 8th row b to the power of 4? Yeah? So, for instance, let's just extend that a little bit. So we're looking at NR. So if I say to you, same this one, make it a bit simpler, a plus b to the power of 9, I want to know the term in a to the power of 2. So you would then tell me what? It's going to be a to the power of 2, b to the power of 7, and in this bracket would be written what? 9, 9, 2, or 9, 7. They'd be expected to see 7 because it's what goes with the b. However, now we can't leave it like that. I need to know what 9, 7 equals. What is the number that 9, 7 represents? So if I wanted to, in Pascal's triangle, what I would now do is have to write all the lines up to the 9th line. And then go along to where it's b to the power of 7. Yeah? We're not going to do that. Because we have a formula. So NR is, have you got your formula booklets with you? Have a look in your formula booklet, see whether you can find it. And I'm hoping, well, you'll probably go, huh? Exclamation marks. So NR is it, I'm trying to remember off the top of my head, N exclamation mark over N minus R times R, is that what it is? Either way round, multiply. Okay. Now, the exclamation mark doesn't just mean do it with a surprised face. Okay? It's not like 9 but make it surprising. Alright? N exclamation mark actually means something.
Like if it's for example, if it's 7, it's 1 times 2 times 3 times 4.
Yeah.
7.
This is n exclamation mark is actually pronounced n factorial. Okay? N factorial. So, how do we use it? Well, in this case, if I want to know what 9, 7 is, I have 9 factorial over 9 minus 7 factorial times 7 factorial. Okay? Now, of course, that doesn't help you know what factorial means, but Nikita did just say what it means is 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 all over, what's 9 minus 7 factorial?
Oh wait, no, 2.
No. Is it? 2. Okay, 9 minus 7 is 2. So 2 factorial is 2 times 1. So that's 2 factorial. And then I've got to multiply that by 7 times 6 times 5 times 4 times 3 times 2 times 1. Now you're looking at that going, oh my god, all that multiplication. How do I do that without a calculator? Because you will need to be able to. Is there any simplification to be done there? Yeah. Cross all this out, can't we? Get rid of it. So we're actually left with only 9 times 8 all over 2. So what's the answer? What's 9 times 8? 72 over 2. So the answer is what? 36. So we reckon 9, 7 is 36. Should we just check? Up here, look. 9, 7 would be, well, 9, 0 is 1. So we'll go up here. We've got a 1 there. So that's 9, 9 would be 1. 9, 8 would be 9. 9, 7 would be 28 plus 8 makes 36. So we agree. That gave us the right answer. Right. 36 is the correct answer. So now to complete this, what is the term in a squared for this expansion? 36 a squared b to the power 7. That's the term. This is your answer.
But what does that actually mean by factorial? Like,
That's it. Multiplying 9 factorial. 9 times 8 times 7 times 6 times 5.
So all the variables.
All of them.
Why is it 2 times
Do it on the calculator.
Pardon?
Why is it 2 times 1?
Because it's 9 minus 7 is 2. Factorial. 2 factorial. Yeah? Multiplied by 7 factorial. So here is the 2 factorial. Multiplied by 7 factorial. Yeah? Right. Now, there is also a calculator method to do it. However, you need to be able to do this. This will be a non-calculator paper question to be able to find that. Right? Now you might go, oh, how am I supposed to do 10 factorial? Well, 10 factorial, 10 times 9 times 8 would take you a long time. But in reality, you never have to do 10 times 9 times 8 times 7 all the way. You only get left with, like we see here, there's only 9 times 8 actually left to do once you've simplified. Okay? It's easy. Not going to be difficult. The division, is the division ever going to be hard? It's always going to end up being a whole number. There's never going to be any decimals because none of the coefficients are decimals. Therefore, this finding the coefficient without a calculator is expected to be an easy question. Right? However, in a longer question, they might let you have the calculator just to get that done quickly. Right? So there is a method to do it quickly. Right, so that's what we're going to look. So let's have a look whether we agree 9, 7 is 36. Let's check. So if you've got your calculators, right, I'm just checking whether I remember where it is. Can't remember where it was myself now. Let's just have a look. Okay, so just to show you how you find it. So you're in the, so what is it? The math button, because it's a math process. So press your math button here, right? Across the top, you've got these options. It's actually a probability, and when we get to a probability of distribution, a binomial distribution, you'll see why it's probability. But we go across to it being probability, okay? And you've got number 3, you've got the NCR written in that way that I set up here, look, NCR. So what you do is you go down to that, press enter. I need to get rid of that answer. So again, math, cross to PRB, down to NCR, press enter. Right, gives me answer again. It's because in between, before I press it, what I've got to do, let's delete that, and before NCR, I've got to put what the N is. So in this case, what's N? 9. So I've got 9, math, probability, NCR, right? And what's the R? 7. If I do that, press enter, we'll get the answer 36. Alright? So can you tell me quickly what, let's go back to this one. Can you go through what is, what do we have? 18.7. What's the coefficient of that one? And then, can you prove that by doing it without your calculator, or do the multiplication maybe, but use the formula. Find 18.7 using your calculator and by using it. Just check you can do both. Alright, check you get the same answer. So, 18.7. So on your calculator, we're going to type in 18, math, go across, NCR, 7, press enter, we get the answer, 31824, 31,824, that's a big coefficient. Can you at least write out the formula and prove it gives you the same answer? Using your calculator to do the multiplication, but at least show it does that. Okay? So we're looking at doing this with the calculator. So I've got 11 factorial times 7 factorial. I've done that. Also, what you will need to do if you've got no calculator, you're going to have to simplify as much as possible. So for instance, I know the 11 factorial disappears. So I've got 18, 17, 16, 15, 14, 13, 12. All over 7 times 6 times 5 times 4 times 3 times 2 times 1. Is there any further simplification that can be done? Well, 7 with 14, that makes a 2. Okay, 6 with the 12 makes a 2. Anything else? 5 with 15 makes 3. 3 with 16 makes 8. 2 with 18 makes 9. The 1 then doesn't count. 4 with 2 and a 2 go to make the 4. True. I did that wrong. I was thinking 18, wasn't I? Anyway, I've messed that up. But you can cancel everything on the bottom with what's left, and you get left with a calculation to do. Right, but you're right. I messed up. That's in my head for some reason. Right. Now, Children, pay attention. Otherwise, when you come to take a test, you're going to be copying him next time, aren't you? And getting it all wrong. Right, we've got to expand this a little bit further, okay, in that it's not always A plus B. So, for instance, if I said to you, expand 3x plus y to the power of 4. Okay, this is what we're going to get onto. So I know I've got 3 minutes to go for this, and then you've got a couple of examples to do for homework, obviously. Right. So just to prepare you, right, if you turn page 187, so this will all be on the video, page 187, we're looking at exercise 6N, right? You can have a go at doing exercise 6N. So I'm going to go through one now, similar sort of thing, right? You're going to follow this through with me and it should give you enough information. So in this case, we are still using the A plus B to the power of 4. So what we know is A is 3x and B is y. Now if it was minus, it would just make minus y for B instead. But what we can use is use this expansion. So what's the first term of this expansion? A to the power of 4. So it's actually 3x to the power of 4, not 3x to the power of 4. 3x to the power of 4 plus 3x to the power of 3 times y plus 3x to the power of 2 times y squared plus 3x times y cubed plus y to the power of 4. Got that? A to the power of 4, A to the power of 3b, a squared, b squared, a, b cubed, and b to the power of 4. Alright? What's missing? The coefficients. So in front of here will be 4, 0, which is always 1. In front of here will be 4, 4, which is always 1. And then here it will be 4, 1, 4, 2, 4, 3, and so on. How do I finish this question off? By working out what 4, 1 is, what 4, 2 is, what 4, 3 is, and so on. Okay? So, I'm going to get you to do exercise 6N for homework, please. Next lesson. Is it tomorrow already? Have we changed time to it? Okay. Can I get you then to do the first 4? Question 1 to 4. So not all of them. We'll do question 1 to 4. I need you to do this. You need to review it and practice it. Okay? I'll make sure that this is...